Doc, the physics of sound and music, we have a request to review circuits. Here is part 2 of our circuit review. We'll go to chapter N here, call out the chapter. And in this chapter, we see first a setup that we talked about earlier where we have the source, a detector, an amplifier, and speakers. The 3 steps in reproduction of sound. And we looked at the turntable, the record player. We've looked at the tape deck. And in this section, we're going to look at the tuner and the amplifier. And in the previous chapter, we talked about the speaker. First thing here with vacuum tubes, you don't need to know this. This is historical. In the old days, vacuum tubes were used to do the same job as diodes and transistors. Now this one we're showing here is actually the triode vacuum tube, which does the job of a transistor. Interesting stuff to look at, not needed for the course, although rock musicians still love vacuum tubes for that twangy sound over the solid state transistor alternative, which is the modern invention from 1948 when this was invented. This is about the turn of this century, like early 1900s, very early 1900s. All right, what's the first thing we need to know for this chapter is the amplifier. The amplifier is simply understood in terms of a transistor in a basic way. Transistors, we have seen, can be used as a switch, where you basically have something come in the back door, then this fires up, or if nothing goes in the back door, this then is off. So you have either a 0 or 1. And computers use zillions of transistors for various computer technologies and little chips. So here we see that we're using it as an amplifier where you have a little dance here in the back door in step like this. See? And here, since you have big time voltage ready to go, battery not shown here, but plus and minus indicated by here by this ground symbol, the negative, then this is your river, this is your stream, and as the stream dances, the river will dance in step due to the tremendous voltage here that you have for your river, and that's amplification. This becomes this. So that's the first thing that is new in this chapter we need to know. And then the other main thing is the tuner, which we learned by analogy with resonance involving mechanics, the mechanical analog where you have a ball on the end of a string and we shake the string back and forth, and if we go back and forth at a low frequency, we don't have much of a response. If we go very, very rapidly, then the ball will simply hang straight down, not move at all. But if you go at some intermediate frequency, the ball goes crazy. So you have this kind of a graph for the resonance. We have electrical resonance with this circuit, the inductor, capital L, a coil, the resistor, capital R, the resistance, and the capacitor, capital C, a learning resource center, or a learning resource center. So here this LRC circuit does the job, and here's an analogy. Now the text will explain in more detail why the inductor acts like inertia. I'm not going to do that. That's beyond the scope of the course, but it's in the text if you want to read it on your own to learn more about those subtleties. But here I'm just going to state that the inductor acts like inertia. Inertia is something that you have with a mass. If it's moving, it wants to keep moving. So when that shoe on the end of a string is wiggling back and forth like a pendulum, it overshoots the equilibrium position, goes too far to the other side, and then gravity pulls it back. And then there's air resistance that, and various resistances help it, die down. So here with the electrical circuit, you have resistance in the form of a resistor. You have the coil, which serves as inertia. So if current's going through that, when the current starts to die down, there's sort of a little bit of a resistance there, and the current keeps flowing. It takes a little while to die down and does the overshoot. C is like your gravity. If you have too much plus on this side, it wants to spring back and go the other way. Just like when your ball on the end of a pendulum is too far swinging on one side, the gravity pulls it back to make it go the other way. So think of the capacitor like the springiness, a restoring force like gravity. So all the pluses here, say, at one given moment, they want to then go the other way. And when they go through the inductor, they overshoot, they go too much and pile up here because of the inertia. And then after a while, then too much gets here. The inductor eventually the current does stop. And then here, though, the capacitor says, hey, get away, get to the other side. They start moving the other way. So you have an oscillation here. You have a circuit that wiggles in terms of electricity. So here we have a driving force coming in the electromagnetic wave coming from the radio station, and the antenna here helps it grab onto it. And this is like your hand shaking the ball at the end of a string, and this is your electrical current here. It's going to wiggle back and forth like the ball. And when we come in at the right frequency, we have the resonance effect. The resonance effect meaning we have an effect that's just like this, where this is the signal strength that you have in the circuit because it's going crazy if you're at the right frequency dialed in. So to dial that in, we have a little arrow usually you see here that lets you adjust the capacitor value so you can dial in the different radio stations. Well, the next thing we need is the diode to help us understand the radio, the amplitude modulation AM radio, and that is a device that lets current go one way. It's a one-way sign, like a one-way street. So in other words, the current here that would like to go this way, the arrow says, yeah, you can. Yeah, you're going the right way. Go ahead, go through, come around. That's good. Here, the current wants to go plus, wants to go to the minus, comes this way, hits the brick wall, says, nope, nope, that's the wrong way. You can't go. So no current flows here. No current flows. It's blocked, and here you have current. This is needed to understand demodulation, where you extract the modulation of this wave. This is an amplitude modulation, where the amplitude up and down, and this represents a lower frequency. Say it's the frequency of your flute player playing a flute note, and here's your radio wave coming in from the radio station. So we just want this top part, see, we just want this top part, which is going to be our audio wave. When we put it through a speaker, we can hear it. So that's the top part. Think of this wave as shaking electricity in a circuit, pushing a circuit electricity one way and then pulling it back. Pushing it, pulling it back. Pushing it, pulling it back. This says when you push it through, it goes through. You can't have the lower part, which is the pullback part. So that means you just get the top part, and the top part is the signal that you want, and that's your modulator part, and that's the second stage in the radio. Here it is, which shows you the variable capacitor to tune in to get your favorite radio station. And this radio circuit here, this tuner, when you tune it in, this will go crazy when you have the right frequency that the radio station is broadcasting at. You get that modulation coming in here in this form. You just want the modulator part though, so you have the diode to strip off the top part, and then you go to an amplifier, which we already talked about. Little steps here in the stream backdoor section, and then the main river here dancing in step with this, which is a larger amplitude, that this voltage fluctuation gets picked up and sent to a speaker. And there you have the radio. And that is it for this chapter.